In this video, I'm going to go over an example ACT problem that deals with finding the function domain. So what is the domain? This is the complete set of all possible values of the independent variable. And typically our independent variable is x. And our range, that's a complete set of possible resulting values of the dependent variable after we have substituted the domain. And our dependent variable is typically y. Now we usually write the domain and range using interval notation. Interval notation specifies the lower end and upper end of the domain or range. Square brackets are used if it includes the number, and parentheses are used if we do not include the number. So if you see a domain like this, -2, 5, these are parentheses. That means these are numbers from -2 to 5, but not including -2 and not including 5. If I have this, this is saying numbers between -2 and 5, including -2 and 5. This one will say numbers between -2 and 5, but not including -2, but including 5. Now, when there really is no upper end or lower end, we use infinity, this symbol. So your domain was all real numbers, which means all numbers are valid. The interval notation for that would be negative infinity to positive infinity. So we use parentheses because infinity is not a number, so it can't include infinity because infinity is not a number. Now we'll have restrictions on our domain when certain things happen. The first one I want to talk about is division by 0. So any value of x that causes a division by 0 will be excluded from your domain. If we look at this first one, we have x minus 5 in the denominator. If x was 5, it would be 5 minus 5, which would give us 0. And we don't want division by 0, so x equal 5 will be excluded from our domain. Another restriction is when you have a square root of a negative number. Now when you take a square root of a negative number, you get an imaginary number and not a real number. So that's going to be excluded from your domain. So here we got square root of x minus 3. If x was -3, and that would give us 0. If x was -4, that will give us -1. So we don't want any value less than -3. Okay, so our domain will be values that include -3, and then anything higher, so it goes to positive infinity. And our third restriction is you don't want to take a logarithm of a 0 or negative number. So here, 2x plus 1, I want to find out what value of x makes this 0. So I just set it to 0 and solve for x. So I'll subtract 1 from both sides. So 2x equals -1. Divide both sides by 2. So x equals -1/2. So my x value needs to be greater than -1/2. It can't be -1/2 because that'll give me a 0. So basically my lower end with the parenthesis be -1/2, and then to positive infinity. So this is our example ACT problem. Two real value functions are defined by f of x equals square root of x plus 3, and g of x equals the quantity x minus 2 to the third power. What is the domain of f of g of x? So this involves function composition. basically plug in the g of x function for x and the f of x function. So f of x, f of g of x will equal square root of x minus 2 to the third power plus 3. So I just took what was the g of x function, plugged it into x and the f of x function. And now we want to know the domain of this. So this deals with the square root, so we need values underneath the square root to be 0 or greater. It can't be a negative number. Square roots of negative numbers are not allowed in the domain. So if we look here, if I set that to 0, if I add 2 to both sides, x equals 2. Anything less than 2 will give me a negative number underneath the radical. And it's cubes, so it'll still be negative. So when I write my domain, it's going to include 2, and that's our lower end, and then it can go up to positive infinity. So our domain is from 2 to infinity, including the 2.